Okay, let's have a look at question 2 from your quiz 4 in BAMS 506 here. So let's say we have the following problem. We have three variables, x1, x2, x3, and we have this general set of constraints. Nothing's been specified for what these numbers are. Now, after that, these difference variables are added in. So let's have a look at why we would do that. Something to also note, there are 3 variables, but 4 equations. Having more equations than variables can be problematic. Okay, so let's go and have a look here at a sample version of this kind of setup, if you will. I've just made my variables x1 through x3, and then I've made some constraints. I just picked some numbers at random here for my a11, a12, a13. I did that for all 4 equations, and some more numbers for these guys. And I'm just doing this, I'm grabbing some numbers at random to show you where this problem is kind of going or why we're going to do what we're going to do. So bear with me here. Now, something funny, I have defined my coefficients for my objective to be zeros so that I actually don't even really grab these numbers. 0 times these numbers is just 0. The reason for this, it doesn't actually matter what happens with the objective function. All I'm looking to do, I'm just seeing if these constraints can be satisfied. That's it. So it doesn't matter whether you call this a max or a min. Doesn't matter what you do there. This is just kind of one hack, is to make your coefficient 0, go solve in solver, and it will see if you can satisfy these constraints, which are these ones here. So let's go pop this in here. Go hit solver. I'm just going to maximize it again. It doesn't matter how you do it. And the key here is that I'm solving for these left-hand sides greater than or equal to the right-hand sides and seeing if this is possible. Click OK. And this is the problem we are encountering. So what we were trying to do was see if it was possible to satisfy all of our constraints. Okay, and it turns out it's not. Solver could not find a feasible solution. So this can happen in some of your LP problems where there is no feasible solution. It's impossible with all the constraints that you have. And so what you can do is relax some of those constraints, if you will, or make them more soft by adding in what are called these differences. So what we couldn't do is we couldn't manage to get these left-hand sides above these lower limits, if you will. We couldn't manage to get over the B1, B2, B3, and B4, whatever they happen to be. I just grabbed numbers at random here. We couldn't make that happen. So what we're going to do is add in these difference variables. And there's 2 reasons for it, or really 1, but what these differences are is the amount we're not meeting this limit by. If we want to minimize them, then we're minimizing, in this case, how much we're off by our limits here, if you will. So how much we're under. So if we can't quite reach the 17 through 20, we're going to be lower than those numbers. We can't quite reach them. But what we're going to do is we're going to allow for this difference variable. And that will get us as close as possible to these limits if we minimize the differences. So I'm going to go add those difference variables into the problem now. Okay, so I just created all these new columns for my differences. I'm just going to put them up here with my variables and treat them as variables. My objective now is going to grab all of the differences. And again, I'm going to do the same hack and just use zeros here for now, and then I'm going to shift it in a sec. Actually, no, scrap that. I'm going to jump straight in here. Let's jump straight into using our, sorry for the confusion there. Let's jump straight into using our D1, D2, D3, D4. So we're going to do 1, 1, 1, and 1. So that when we do the sum product, we're going to get D1 plus D2 plus D3 plus D4 for our objective. And in this case, we want to minimize it now. It does matter. Good. Okay, we can copy this formula down now the left-hand sides, and what we're going to introduce is one of the D1s in this equation, one of the D2s in this equation, one of the D3s in this equation, and one of the D4s in this equation. And these are kind of our buffers. This is how much under we are, so it's kind of, we're just overinflating the left-hand side with these difference values, and then we're minimizing to try to make this total as low as possible. And now go rerun solver, and we're going to switch this to a min. We're going to change now, instead of just those guys, we're going to change all of these numbers. And then our constraints are going to be the same as before. They just have these new values in them. And then go click solve. And now we don't get an error. Okay. Now we get these differences. So we didn't need to change equation 4 at all. That difference is 0. These three, this is the amount they're under the upper right hand, or the right hand side by. So 18.5 to 10.3, and 32.8 is the best we can do if we're just minimizing the sum of them. And so in our quiz question, let's have a look at that now. So the question asks, what does this LP do? So what we're trying to do is meet our objectives here of being at least 17, 18, 19, and 20, or if you will, these any numbers B1 through B4. We can't quite make that, so we're going to get as close as possible by minimizing these differences here between what we could get to and this right-hand side. So here we go. It minimizes the total amount that any left-hand side original row are below their corresponding right-hand side.